and it's all orchestrated. I will start and Anand will finish. So we will be talking today about future and future-proofing confidential AI. And again, today, inspired by Mark Ruzinovich's bravery, he usually presents demo live. So I will try this time to do the same and present to you very fun live demo as well, Mark. Okay, let me start. So again, you know who we are, and Anand will join me momentarily. So when our customers coming to us and talking about confidential AI, they have three things in mind. Number one, they want to ensure that our most and highly privileged administrators would not be able to see the data, the models, or agents that they develop on GCP and deploy to GCP. They also demand that their highly privileged admins, would not see data and models because they want to isolate their own highly privileged insiders from these things. And they want to ensure that it's not contractual agreements. It's actually hardware enforced, attested, and verifiable capability and policies that we will deliver to them. And again, we are not talking about confidential VMs anymore. We're talking about confidential systems. And those systems is actually including CPUs, confidential head. Again, it's built on hardware capability coming from Intel and AMD and other vendors, connected to GPUs, NVIDIA GPUs. And again, the communication between them, network storage, are all confidential. And with new technology, exactly as mentioned before, TDs, when all of these encryption is happening in hardware, we see significant ability to provide performant, latency-free capability to our customers. So we, as Google, and honestly every other cloud provider, have different GPU capability, different confidential system for every single AI workload. We started with H100s. We enabled single GPU because we didn't have ability to provide performant communication between multiple nodes. We moved to Blackwell, confidential B200. Right now is used by a few customers. One of them you already know is Apple and a few others, but we will bring it to a much broader set of customers as we're working on that. And literally today or a few days ago, we announced availability in public preview our mid-size GPUs. Our customers bring in their domain-specific models and agents that need those mid-size GPUs. They don't need these multi-GPU monsters. So we bring in this confidential GPU to them, combine, and again, with our compute services in our Kubernetes GKE services together. Everybody talk about sovereignty. So no surprise, it's definitely significant effort and investment on our side. Google has multiple offers for customers. We have ability to provide for them distributed cloud environment when they can take multiple racks and again deploy in their data centers. We offer Gemini for those customers, and as you can imagine, Gemini required significant protection. So we're running Gemini in confidential computing environments to ensure that this IP that we highly value, exactly as IP of our customers, is protected. We also have in France and Germany dedicated cloud environments run completely by different partner operator, ensures that Google and Google insiders never have access to any of services and capabilities over there. And from my specific team, because I own Encryption in Google, we're also introducing for sovereign customers this what we call confidential external key manager. And external key manager is the ability for customers to have full possession, control, and transparency for their keys. We're utilizing confidential compute environments for this capability and also protecting every single cache of their data encryption keys in our possession to ensure it's fully confidential. And when I'm talking about anything cryptography related, I can't miss my wonderful volley. So again, as you can imagine, the cryptography is now not only AI coming toward us, but also advances in quantum computing is becoming absolutely possible. Google introduced dates, commitment to our customers. We will move all our services, all of them by 2029, fully to post-quantum cryptography. And it means internally, we need to do it much sooner. And it's significant undertaking for us and industry and our customers. We've done some good jobs there because all our traffic internal for all customers' data is already quantum safe. We also use Chrome. If you use Chrome, you're in good shape. And also all our external, again, networking systems, load balancers, and everybody is also quantum capable. So we are moving really heavily in the world when post-quantum is becoming reality. So to, again, summarize all of that, because we don't have too much time, data in mind, as I started this conversation, is very much in mind for us. We're also talking about sovereignty and capabilities that confidential compute can offer for sovereignty, and post-quantum readiness in absolutely critical part that all of us need to contribute to. And now, demo. Let's see how I will do it. Can we switch to my system, please? My password was not revealed. Good shape. Okay. Okay. Interesting. Okay. Please. Yes. Good. Okay. So the demo is called Data in Mind, no surprise, in agentic AI. And the use case that I want to present to you in this short demo is very basic. Company A and Company B. Company A is evaluating Company B for their M&A evaluation, and there's usually Company B sharing every single possible sensitive piece of data that they possess, the code, their environments, everything, their business, revenue numbers, everything possible. The worry that we all have and our customers is memorization. Memorization and decay, because this data is actually in agents' minds. And when, again, distillation happening, all of this data is stored. So re-engaged agents would be able to use it. In this use case, I prepared my environment, so you will not spend too much time waiting. But I have, again, confidential TEs, right, running. In these confidential TEs, I will run 2 agents that will do this evaluation, M&A evaluation, because time will come when those intelligent agents will do this work for us. So you will see it live, and we'll see what we will do. Also, those agents have their dedicated keys. We called it auto key. It's generated for those agents, so they would be able to protect those memory distillation information that coming to, again, file store or SSD. So let me simulate, again, those agents. So 2 agents in this particular thing. So audit lead agent is continue to analyzing, and code agent is also analyzing. And the sound is exactly the right, because the drama is coming. I love that. It was not staged. So context window reached. 100%, because it's so much data that they actually processing. And what will happen right now, distillation, again, event will hit. And now the whole data, or partially all of the data in their active memory will be shoved into LLM to provide the most important facts that those agents need to remember to continue their investigation. In my case, the agents, they're not malicious, they encrypt this data. So as you can see in my demo, if I will verify the decryption is happening, and those agents would be able to continue evaluate the documents that they need. But in case M&A will not go through, or you need to remove this piece of memory from agents' minds, you crypto shred it. And I think it's one of the most important things that we need to remember, ability to clean this memory. Short-term memory and long-term memory. And short-term memory, as you can imagine, can be cleaned when I will kill my CVMs, my Ts. But for long-term memory, I'm crypto shredding those keys. So now you will see that this demo is not fake, because I may fail when I will verify the wiped agent memory is actually wiped. Maybe it's not, because as you can see. Okay, let me try again. We again have some time until we percolated all of these disabling things. Okay, one more time. Come on. The final time, I'm sure it will happen. Please be with me. Yay! Okay, so decryption happened. Thank you. Decryption happened, and we finally get rid of these things. So if agents will continue working on this particular data and this particular code, we can rotate the key and continue running this environment. But when we don't want that and want to kill everything, we're simply destroying the environment. So it's how we'll ensure that data that our agents have in their mind is actually not only protected, but deterministically destroyed. Now, the next, we will see, where's my clicker? Now I want to switch to the slides, please. And Anand, please join me.
You know, it's a tough act to follow when you have to follow Mark and Nelly. But I guess as a foundational provider, that's the price you pay. My name is Anand Pashupathy. I run product assurance and security for Intel. I was on the stage 2 years ago where we were talking about how to find the money with confidential computing. I was giving all these examples. One of them was Mark's credit card example of how people are protecting valuable assets with confidential computing. And at that time, we had started talking about the importance of AI. It was just beginning. Everybody was saying that's the fuel that's going to drive confidential computing. And here we are today. When you look at some of the research data, 75% of the enterprises are using some form of confidential computing. And from an Intel perspective, trust domain extension, which is a foundational technology for confidential computing, is being used by my friends at Microsoft, at Google. You see all the other global cloud leaders doing it. Top enterprise environments are using Intel TDX. And we have a great partnership with NVIDIA from a confidential AI perspective. I still believe AI is at a tipping point. And there is a significant amount of friction that exists from just people trusting the technology, regulatory compliance, and just the protection of the data and models. And this friction has to be eliminated, and I have an assertion that Intel TDX is your WD-40 to eliminate this friction, because it gives you hardware-based isolation so that nobody can see what's actually happening inside the confidential VM. Your infrastructure provider cannot. Nobody can inspect the workload. So that's the isolation piece. The attestation, Mark talked about it, Nelly talked about it. It's a very critical element where you can actually attest to the integrity of your confidential VM system. And last but not least, you hold the keys. Pardon the pun, you hold the keys to your data and you control who has access to it. Now, if you just look at building on this stair step from towards value, the value really is revenue, efficiency, gains like that, but it has to be built on some level of trust and safety. The utility will come through training and tools and all that, but how do you make sure that the infrastructure is trustworthy? And this is where Intel TDX comes in, because it gives you that isolation, the attestation, and the control to make sure that you can, as a customer of the system, focus on value. There are a range of confidential AI solutions that are available today. So if you just use the CPU with AMX, which is the active matrix extension technology from Intel, you get about 6x against a system that doesn't use it. And it's really for small language models, it's for machine learning, agents, etc. But if you want to get a system which includes a GPU for larger language models, a bounce buffer or an encrypted bounce buffer solution is what is available today at GCP as well, where you can now share data between the CPU and the GPU, but with software. And as my speakers before talked about, the TDIS protocol is coming, and we are building our TDX Connect solution with it, where you'll get line rate traffic between the CPU and the GPU. And at the end of the day, all of this is wrapped around with Intel Trust Authority, which gives you independent attestation from a multi-cloud, hybrid cloud environment. And towards the GPU spectrum, you get one attestation. So you get the attestation for the system rather than one individually from the CPU and one individually from the GPU. Okay. The other topic we kind of touched upon was data sovereignty. A lot of people have been talking about data sovereignty more from a location perspective, that if I'm within the location of a country, the sovereignty of a country, my data gets protected. But then at the end of the day, one simple mistake, one simple configuration issue, that data will get exfiltrated to regions that it's not supposed to go to. So you need to give access to that control in order to get complete data sovereignty. And this is where my assertion is Intel TDX also plays a role, because along with geolocation and with verification that the data is actually protected, because you control it, it's the same, isolation, attestation, and control, you can give full data sovereignty. I'm going to switch topics to PQC for a second. Intel, again, as a foundational hardware provider, gives you two different approaches to PQC. The first one is just how do we support PQC in our platform itself? And that conversion started with Xeon 6. And we will go through this transition till 2029, where all future platform generations will support PQC. Now, we're also trying to accelerate algorithms in hardware, and we support AES 256 today. You can use that acceleration in order to protect against harvest now, decrypt later attacks, and we'll continue on that journey as we add additional algorithms to accelerate. The bottom line of all of this is I'm with Mark. I think this year, if not in the next 12 months, is going to be an amazing time for all of us to be in this industry, because AI is absolutely going to fuel confidential computing. Thank you for listening to me. It's great to be here, and we'll continue the conversation.